Assalamualaikum. Our final project is anomalies detection for surveillance. For the project, my group members are Waji Ahmed, me, Suhail Nasir, and Nusherwan Iftikhar. First of all, I will start from the main objective of our project, that is to detect any anomaly or any irregular activity that may be prohibited in the most of the institutes. And second is to ensure the safety of everyone. The potential anomalies for our project are weaponry, violence, fire, and smoking. Then I will explain the perspective of our project because we have created this system to make it to add this security to the already present surveillance system. But there are few anomalies in our project, but we can add on new anomalies are the features to make our system more proficient and applicable to majority of the places. We want to make our surveillance system autonomous so that we can avoid the presence of security guards or any other person that usually spend their times in front of screen. If I explain the technical details of our project in some aspect, we are using the Python language to develop our system, and the operating system we have used is Windows operating system. And then the neural network we have used is YOLO version 4. We have used this YOLO version 4 algorithm because it is fast and detects anomalies in the real time. If I explain the applications of our system, we can implement our model or the system in the real-time surveillance, schools, colleges, uh, and picnic places, and any other place where we want our surveillance better and better. This will make our system autonomous and add more security features and instant responses. Now, for the next portion, I would like to call my colleague Nusherwan Iftikhar. So,
Now I'm going to explain you the front end of the application. We have kept the front end very simple and interactive. As you can see, moving forward to the next slide, as you can see that we have designed this in a very simple way. So any user without any prior knowledge can access the application without any difficulty. First of all, you can see the interface on your screen. In order to apply a detection on the any image or video, you should click on the upload button to upload the image or video for the detection. Once you have clicked the upload button, the next screen will appear. In this screen, as you can see, there is mention choose file. Once you have clicked the choose file option, you can select any video image from the Windows Explorer. So you can apply detect, so the application can apply detection on that image or video and give you the desired result. Next slide. Okay, the model we are using is YOLO V4. Mm, as we have used YOLO V4 for real-time detection for our application, and we have trained the models on the following network. As you can see, uh, as you can see the neural network model. Move to the next slide, please. We have used this model, neural network model, to we have used this model to Okay, now Vaji will take over.
So as I'm Waji Ahmed with registration number FS17PCS026. As my colleague Noshirwan Iftikhar was explaining that we have used YOLO V4 for this project. YOLO V4 is one of the state-of-the-art object detection algorithm that is being used for real-time detection. And as you can see that this neural network is very in-depth, and due to its in-depth structure and architecture, it is able to make detection fast and on real time with high FPS. Moving forward, I will be explaining you how this project of art, that is anomaly detection system, will work. So basically, what we are intending to do is that we are going to take the data out of the DVR system that is already installed for with the cameras installed at the premises. The DVR is basically providing the video stream of those cameras. Those cameras feed will be fed into our detection anomaly detection model, and on each frame that is being taken from those camera videos, we are going to make an investigation. We are going to make a detection for anomalies in that particular frame. Moving forward, I will show you the pictorial diagram that will explain how it will work. So as you can see that the CCTV cameras are already installed. Those input is being fed into the DVR system that is already installed in the premises. Now, what our system will do is basically take out the output of those DVR and take it into our model, that is anomaly detection model, and make a prediction. Those prediction would include the potential classes of violence, fire, or weaponry or smoking in the premises. Moving forward, I will be explaining you the code that I have used in order to make this model work. For that purpose, I will take you to my Google Collaboratory so that I can show you the notebook in which I have created the code. Welcome to my Google Collaboratory. As you can see that in this notebook, we are using Tesla T4, that is basically a GPU provided by Google in order to run our model detections and in order to make our model. As you can see, as you know that this model is going to be a heavy one and we need such type of high powerful GPU in order to make a detection. Here, what I am doing is basically getting my drive setup that has all the data set that we have gathered. We have gathered a custom data set. We have 4 classes, and for those 4 classes, we have gathered a custom data set using Google. We have used open image data set and a lot of raw images as well. And then we have annotated them and get them all bunched up in order to make our model more accurate in terms of data being provided to the system. As you can see that this whole ARM dataset is being loaded, and then we have this dataset being loaded from Kaggle that was related to our violence dataset, and we have done some pre-processing in order to make text files out of it that contain all the annotations in regards to the anomalies in the systems. And we have made certain installation of certain libraries that we are going to need in our systems. Moving forward, I will swiftly take you toward the area that where we have started our training of the model. So basically, as you can see that we have to preload some weights into the model. So we are using these YOLO V4 convolution 137 layer weights at the initial level so that we can give a start to our model in order to make in order to get training started. Then we have trained it for like about it took about like 3 nights continuous continuous training in order to achieve the results that we have been able to up to about plus 90% accuracy in order to make detections for anomalies. This is some screen recorded versions of how the training has been gone through. And if you can see, this is basically where we have computed how well the model has performed. So as you can see, the true positive and false positive being shown in here, we have four classes and a basic. We are using 2 weaponaries because we are using handguns also a heavy weaponry. So we have classified them into two weaponry classes. We have an accuracy of 95% for weapon, 98% for fire, and for violence we have an accuracy of 97%, and similarly 97% accuracy for smoking. The overall IOU matrix was about 0.007, and we have been able to achieve more than 90% accuracy in our model. As you can see, the precision is about 94%, the recall is 97%, the F1 score is about 95%. So overall, our model is very highly efficient model. Then we have tested some certain objects in terms of getting the result, how well the system is performing. So this is an image for detecting the smoking. It is about detecting about 77% that it has detected smoking. Then what we have done is that we have computed this model into a file so that we can use it anywhere we want to install the system. So that's these are the required libraries that we are downloading in order to make that system. Then this is the model structure we have in here, and we are basically saving the weights in the in our local backup in order to use this with those backup for installation of the system at wherever we need to. Now I will take you back to my presentation in order to show you what were the training results and moving forward. Welcome back to the presentation. Now I will take you forward to the training metrics, or the chart you can say for how well the model has performed. So the model accuracy, as you can see, it is around 90, more than 95%, around 97%. It has done real good. Moving forward, we have a model loss. As you can see, we have a very minimalistic loss, and all thanks to the vast data set that we have, so that the model is able to make autonomous decision and more accurate in terms of getting any type of image and making a prediction on that image. Moving forward, we have this confusion matrix that we have shown you earlier as well. As you can see that we have a very great accuracy in terms of our model. We have above 95% accuracy, we can say, and the model is performing really good. Now, as you can see, these are some results that we have taken from our object detection model. As you can see that we have 98% detection of weaponry, 89% detection of smoking, similarly for fire. Also moving forward, we are going to show you some visual results as well. As you can see that it works on videos as well. We have violence detection, fire detection, smoking detection, weaponry detection, all of the classes detecting very well with very high accuracy. Now I will take you to do a tutorial video that will explain you how to use the application. Welcome to our front-end application. It is going to be an application that is going to run on the local host wherever the system is going to be installed. So as you can see, it is a very minimalistic design, We have this explaining how our app works. Basically, in order to make any custom detection model, you can hire us, and we will be able to make that model for you. That we will make an in-depth study of the use case that you want. We will code that use case and then launch that use case at your premises as you need. So let me show you how a tutorial video will work. How would you upload an image and make a detection out of it? So what we will do that we will go to upload. In this screen, as you can see that we have a choose file option. So what I will do is that choose file, we have a pop-up of Windows Explorer. Now let me make a detection on this file. Let's open it and let's upload it. As you can see the result, it is very fast, very accurate. We have the detection of a file. Now let me show you another one. Let's go back to upload screen, choose a file. Let's say we want to make a detection on this file. Let's click it and click upload. And as you can see, we have a detection of 2 weaponaries in this image, and we have also explanation of total objects detected, that is 2. So basically, this was us presenting you the autonomous serverless system with our front end being minimalistic, our back end setup there with a model in hand and making detection on it, we need a very high-end GPU in order to make detections on videos, and as you have seen the video result as well. This was us explaining you the autonomous serverless system, RFIP. Hopefully we are clear in our presentation and able to explain the all working. Thank you so much.